Hello, everyone. My name is Anastasia. I'm a maker based in Chicago, and we are going to talk about making skateboards. But we are going to talk about making skateboards in the lens of on-ramps to digital fabrication or ways to get students into your makerspace that may not otherwise be like, ooh, a makerspace, that's a thing I want to do. But they may see, ooh, a skateboard. I like skateboards. Let me get that. And then we can hook those students in by attracting them with this idea of digital fabrication. I want to share with you this skateboard process because I think it's really fun and cool. And at the end, I want to have a little bit of open time for a discussion for what other ideas or projects are you thinking about or excited about, or you see things that your students are excited about that you might be wondering, how can I use that as a hook to pull more students into my makerspace? So just a little bit about me, how I ended up here. I currently consult with the Fab Foundation as an installer and a trainer. So when the Fab Foundation sets up a new lab, I'm one of the people that comes in and helps set up all the tools. So I've assembled a lot of shop bots and a lot of Prusa 3D printers, and then trained Fab Lab managers on how to use all of those things. I used to work as a technical instructor in a group called the Product Design Lab at MIT. So I was teaching digital fabrication and some manual fabrication and maintaining the lab there. I also used to be the shop lead in the digital fabrication shop at a community makerspace called Artisans Asylum in Boston. Um, yeah, so let's talk about making skateboards. So I'm going to introduce two different projects today, both of which around this idea of skateboards and bringing students into your Fab Labs. The first is making fingerboards. So if you can see my tiny video, I have this very tiny skateboard that you might have heard of these as tech decks or little fingerboards. This is a great project because you can make lots of them. Every student in your classroom can have their own, and they're pretty simple, quick, that require very little materials. And then we'll talk about making actual full-size skateboards that your students can ride out of your classroom, hopefully not in your classroom. And then using additional digital fabrication tools to provide graphics and decorations for the decks of either their small skateboard or their big skateboard, or even the idea of like you can design skate parks, whether those are little skate parks for your fingerboards or full-size ramps if you have a large format CNC or other things like that. And then again, using these as on-ramps. So we're going to talk about the 3D design of the skateboard deck itself. We'll use a CNC machine to cut out the mold and cut the skateboard itself. We use 3D printing to make molds that make the fingerboards. We're getting some composites because a skateboard is a composite of wood and glue. If you're ambitious and have good PPE, there's a bunch of other things you could do with fiberglass, carbon fiber, and epoxy. But to keep this easy and accessible for schools, to get a skateboard, all you need is wood and glue, so no special PPE required other than using your CNC machines. And then we've got, as I said, 2D design using our graphics for whether you're laser cutting, vinyl cutting, or even printing designs that can go onto your skateboards. So that's where we're going to go. So we'll start with these fingerboards. So as I said, fingerboards are great because there's super low barrier to entry. This fingerboard is made of paper and glue, and that's it. And then it has a little bit of sandpaper or traction tape stuck onto the top, as you can see from the pictures there. And then you can buy easily online little kits of the hardware for the trucks and the wheels to make your skateboards from a deck into a skateboard. And so I'm going to switch over here. The way that I make these skateboards is this awesome software called SkateCAD, which is a website, sk8cad.com. I highly recommend you all load it up. You'll be presented with a view like this. You have this nice 3D model of my skateboard. If I'm making a fingerboard, you can go into their example over here and scroll down to fingerboard, and it'll set the presets approximately right for a fingerboard. And then you can, of course, customize it. You can come down here and say, oh, I want to change the way the nose tapers and change the shape of it, and say, oh, I want the tail to be a little bit different, for things, and that will customize the shape of your skateboards. If you do something really weird, like, oh, I'm going to put a bizarro value, it will put in, a nice error message saying like, oh, that value doesn't make any sense. That's not going to work. Try again. So we can. It's very user friendly. You can, and I in fact have had people design their boards entirely on a phone or a tablet. So you don't even need a computer with mouse and keyboard to do this kind of design. And once you have your skateboard looking the way you like, you can come up to the top, and then you can say, now give me the mold. So you can create a two-part mold. So this is one side of your mold. Flip over here. And this is the other side of your mold. And for fingerboards, you download the STL of both sides of those molds, and then you 3D print them. You get two pieces, fit those together, take a couple layers of paper, cardstock. You can experiment with a couple of different materials. You can also get very thin wood and make wooden fingerboards. I haven't tried that yet, but it's on my list of things to try. So you get your 3D printed mold, you get your pieces of wood, and then we'll jump back here. And I have a picture here just showing those 3D printed molds stuck in a clamp, but this is actually way overkill. You can just use rubber bands. You don't even need a clamp. Let those sit aside for 24 hours, let the glue dry. You'll take that out and you'll have a shaped, paper, cardstock, composite board. And then to cut that into shape, because it is made of paper, you can just cut it out with scissors. What I like to do is go back to my SkateCAD. SkateCAD will not only export an STL of the mold. If we look at the board, there is also an option to export an SVG, so it will give you a vector of the profile of your board and where the truck holes go. And so I'll take that SVG and I'll use that to laser cut some just like stair traction tape, and that's what I use as the grip tape on the fingerboards. And so you basically make a sticker that is the tape, you apply that sticker onto the uncut paper board, and then cut it out with scissors, and then you have a skateboard. And then the traction tape will also have the holes marked for where to drill the holes of trucks. So you just take a hand drill or a drill press, drill that through, and you've got your nice tiny skateboard. And then you can build entire lessons around composites and strengths using different kinds of paper, different layering, different stacking. The normal skateboards that I'll explain the process in a minute use 7 layers of wood. So my default is say 7 layers of cardstock is what I recommend. And when I stop sharing the slides, or if you look in the little window, like I can flex my tiny skateboard a little bit, but if anyone's stomping on a skateboard made for your fingers, you've done it wrong. So they're plenty strong for certainly my skills with a finger skateboard, and everyone will be able to have fun with those. So that's finger skateboards. I think this is a fantastic activity. You can do it in 2 days in your classroom. Design, you're going to need to take the time to 3D print the molds. That's sort of the biggest thing that's going to take time. Or if you want to make it more a 2D design exercise, I've done this where I've just come in with a bunch of molds already 3D printed, and everyone makes the same shape skateboard. They get the composites lesson, and then they get to do the 2D design and do whatever art they want on the bottom of the skateboard. All right, so that's fingerboards. We can talk more about that later if you have more questions. Let's get into actual skateboards, because that's where I think the most fun part of that is. But I think the fingerboards are a great hook to pull students in. And when you've got students who are like, this is cool, I'm super excited, I want to see this for real, then we get into full-size real skateboards. So same design process, go into SkateCAD. There's a bunch of preset shapes that are ready to go, and you can customize from there. So if you haven't pulled up SkateCAD on your second screen, I highly recommend you start playing with that while I talk. And so what we're going to do from there is I use a vacuum press method, excuse me, to compress the wood when we get there. And so instead of like the 3D printed molds for the fingerboards, we only need to use one side of the mold. This is what SkateCAD calls the male side of the mold. It's the mold that looks like the what would be the top side of the skateboard, so all the curvature is pulling down onto it. Once you export that mold file from SkateCAD, I take that onto a CNC router. So this is a bit limiting. You do need a CNC router with at least 1 by 3 feet of throw. And the foam block I start with is 3 inches thick. You could go a little bit thinner, but not much. So you need a CNC router that has at least that amount of throw. You can take the design from SkateCAD and take out, look at it in your CAD viewer. And if you're really ambitious, you can carve these by hand. There are still plenty of people who do just take a block of foam and carve it down. But that's going to take a lot of time and a lot of patience to get exactly right. If you have access to a CNC router, a decent CNC router can carve a mold in about 20 minutes if you crank up the speed, because cutting through foam is really fast. It does make a giant mess, so have your vacuum and your dust collection at the ready. But you can blow through the foam really quickly. The next thing you need to do is you need wood veneers. Pretty much all skateboards that are made of wood, there are some like plastic and composite skateboards out there, but pretty much all skateboards are made of Canadian hard maple, which is fortunately relatively easy to get here in the US. It is harder to get elsewhere in the world, but there are companies that do supply that because it is a known thing that people want to make skateboards all over the world. But when we get to my documentation that I'll share a link to, I have a supplier that I like that does, they claim to ship internationally. We had some difficulties when I've had to actually have them ship internationally before. But there are ways to get it. And the trick, if you've never made a skateboard before, is if you're familiar with the idea of plywood, each ply or each veneer of the wood has the grain running in a single direction. And so generally in plywood, just every other layer is 90 degrees off, alternating to make a nice stiff plywood. With a skateboard, there's a generally desired more flex along the length of the skateboard and less flex along the width of the skateboard. And so it's not quite every other. So a skateboard, as I make them, is 7 layers. And there's 5 of those layers are running lengthwise, the grain, and 2 are running crosswise. So you get your grain all set up, and then you just take waterproof wood glue. So your normal Type-On 3. You can use non-waterproof wood glue, but then your skateboard might not do so well if you leave it outside in the rain. I paint the glue on with just a paint roller. So lay out a nice thin layer of glue, stack it all up, put it on top of that foam mold, and then it goes into a vacuum bag. There's a couple different ways to do the vacuum bagging process. There are commercial vacuum bags that you can buy ready to go. Some of them will come with a pump system that everything's all set up for you. If you have the budget for that, it's a nice ready to go out of the box solution. What I'm showing a picture of is a slightly more DIY solution. Is we bought plastic film and this stuff called butyl tape. That's a very soft, squishy, rubberized double-sided tape that you seal the edges of the bag of the plastic film as you go around. And then instead of a vacuum pump, I used what's called a vacuum generator, which is this little tiny thing that is even smaller than my finger skateboard that you put compressed air in one side and has a venturi that creates a vacuum out the other side. And so if you have compressed air already in your shop, one of these vacuum generators costs about $30, whereas a good vacuum pump costs like $300. So if you already have an air compressor, these are a good way to go. And then you just hook it up to your compressed air supply and it'll pull a vacuum and compress your skateboard. The other important part, if you haven't done composites before, is you're going to want some sort of breather fabric inside the bag so that as the bag collapses on itself, air pockets don't get trapped in there. There are commercially available like meshes or special breather fabrics. I've had good success just using off-the-shelf felt from the fabric store. Works just fine. So you pull your vacuum, you hold your skateboard under a vacuum for 24 hours. Again, let the glue dry, and then release the vacuum, pull it out of the bag, and then you have an uncut wooden skateboard, which has the right shape or the right contours, but now you need to cut the actual shape of it. I've done this a couple of different ways, again, depending on what tools you have and how quickly or how accurately you're trying to do it. The first times I did this, I would either laser cut a cardboard template. If you have a big enough laser cutter and piece of cardboard you take that SVG from SkateCAD, just laser cut a piece of cardboard, or if you have a vinyl cutter, you can vinyl cut a sticker that you apply to the bottom of your skateboard and just trace around that with a bandsaw, jigsaw, any cutting tool. What is more accurate and to me more fun, because I like getting into the weeds with CNC fixturing, is mounting the skateboard back onto the CNC machine and then using that to cut the truck holes and the profile of the skateboard as accurately as possible. So it's a bit of mental gymnastics to get the fixturing right. As you can see from the bottom picture on my slide, there's two white 3D printed brackets that first I used the mold to index the mold with the shaped skateboard on top of it back onto the CNC machine. So I knew exactly where it was and drilled the holes for the trucks. And then I took that off, bolted on this 3D printed bracket, indexed that back onto the machine again via where the brackets are bolted onto the board, and then run another tool path to cut the outline of the board. I have detailed instructions written up on my website that I'll share a link to. So if you want to replicate this process yourself, please do. And then once you have a board cut out, let me stop sharing for a second so you can see me. Awesome. So then you end up with something that looks like this. So again, this has been shaped and molded. It has concave across this direction, has nice kicktails, it has the truck's holes drilled in it. It still has, kind of hard to tell, but it has hard edges, coming off the CNC machine. So you're gonna need to do a little bit more finishing. So either with a roundover bit with a router, or my go-to is just with a bandsaw, hand sander, anything to round those edges over. And then you can start adding graphics to the underside, which gets back into what I was saying about 2D design on top of the 3D design project. So if you want to laser cut graphics into this, if you want to vinyl cut as a stencil, and then paint, or just use vinyl stickers as your graphics, there's lots of different ways that you could decorate your board and customize it. And then for finishing, to turn it into a finished skateboard, if you actually want to take this outside and ride it, put some clear coat over it. I just use polyurethane clear coat, brush it on, spray it on, whatever works for you. There's a bunch of different ways to get that done. And then go get some trucks and some wheels. That's all over. Then you got a finished skateboard that you can ride. So this is the first skateboard that I made for myself that I used for a while. To the makerspace that I was based in at the time had two buildings that were across the street from each other. So I'd use that to zip back and forth across the parking lot. And it worked great. So that's the quick version of the process. As I said, there's documentation that there'll be a QR code link to in my slides, and I'll share the link in a little bit. So let's get into where we can go from here. Cool. As I said, I sort of already skipped through this. So once you have your finished skateboard made, the project's definitely not done. There's a lot that you can take from there with 2D design ideas. This is just an example of what one of the people in one of my workshops did, that they laser cut a design for the grip tape for the top of their board, and then used the vinyl sticker as a spray paint stencil for the bottom of their board. Excellent Hitchhiker's Guide theme, so I had to highlight this one. The other thing that I mentioned earlier that I haven't implemented in any workshops that I've done yet, but I think is a cool idea that I'd love to do in the future. I'd love to see someone else do, is taking this a step further, designing ramps or skate parks, whether that's at a small scale for the fingerboards or even at a large scale. One of my personal favorite projects is finger jointed plywood CNC, like large scale objects. So I think, and there's a company that specializes in CNC cut skateboard ramps, that I think using that as inspiration, and if you can figure out the appropriate liability insurance, getting students to design and build their own ramps if you already have a large format CNC, I think it'd be a really cool project. Or the safer option is design small scale ramps, either using the same finger jointed plywood construction but with a laser cutter for small scale things, or even like designing what could become like a concrete bowl skate park, and carving that with either printing it on a 3D printer, carving it out of foam with a CNC similar to the skateboard molds. I think there's a lot of interesting applications there. Cool. So as I said, documentation is available on my website. I can drop the link to that in chat if you want to follow along. Yes, the skateboards do work. They are totally the same as my real skateboard. They can ride ramps and do tricks and all those things. Other things that I'd like to see this go, and ways that you could build upon the project further, is electrifying the skateboards. One of the first things I got excited about when I started doing this project is taking the skateboard build and building out a whole electric drivetrain. I think that would be a lot of fun. Definitely adds significantly to the cost of the project, but it's a great way to build that further, and I think it's a thing that students would find very compelling.
So you have about 3 minutes left. So maybe
All right.
if anybody has any burning questions, maybe you can take a little pause there and see if anybody has any questions they want to jump in with, because we have about 3 minutes left.
Yep. Any questions? The last thing I'll just say is that the thing that I'm working on next with this project is I'm developing a portable low-cost CNC machine, because it's a really cool project, but if you don't have a large CNC, you're kind of out of luck. And so if you follow me on my website or any of the ways that you can find me, that's my next step for this project. But yes, if there's any questions or discussions, like I said, I want to open up the floor for if you have other ideas for cool projects that you can use as this hook to bring people into your space.
I'm curious if you've ever done snowboards or similar skis or something like that.
I have not. The process is definitely similar. The materials are slightly more complicated with getting the metal edges, but I think it's possible. The thing I'll say is commercial skateboards, and it sounds like what Jeff is doing is like I showed for the mini fingerboards, using a two-sided press. And so like commercial skateboards, factories will do a two-sided press, and that's what snowboard factories and ski factories do as well. I have seen discussions of people doing it with a vacuum press, but I personally don't know about how to get those metal edges in there, but it is possible.
We have a student who's doing it right now, and they're now in year 2 of it, and then they're going to be a senior next year. And I think it'll take the 3rd year to get the skis working, because aligning those little metal edges and getting your envelope, the main difference for the skateboard is you're just cutting off all the extra. They don't do that at all when they're making skis and snowboards. It's all got to be a perfectly aligned package, and it's a lot harder. But it's possible, I think.
Yeah, there's definitely things I've thought about with because there's ways that you could, instead of cutting it afterwards, you could like laser cut each individual veneer before you glue it up, but then you need to align those into your mold. So your mold either needs to have like a perfectly set in thing, or you use the truck holes as like pins. These are all things that I've thought about but haven't tried.
All right, so maybe Nick, you can go ahead and throw your link into the chat before they cut us off. People have a moment to grab it. Oh, well, you have it up there too.
Yeah. Right, yeah, so before we get kicked out, yeah, the QR code is there if you want to grab the direct link to my website, but just xsnick.com. If you go to workshops, Skateboards is the first one there. So feel free to follow along. Those, as of all things, documentation is still a work in progress, but I think just about everything you need to try and replicate it is there.